Hello everyone and welcome to another AP Computer Science video. This video we're going to continue talking about arrays and finish up our example where we create some arrays, initialize them either dynamically with the new keyword or with a literal value, and then now what we're going to add is the ability to look through all the values in an array or fill every spot in an array. If you don't remember the analogy I used, it was kind of like one of those accordion folders. It's one object that contains many sections or spots or slots, and each of those slots can hold a single value of a particular type. The two main things that we have to remember for arrays, there are two primary rules. The first is that arrays can only hold objects of one type. So you can have an array of all integers, or an array of strings, or an array of scanners, or an array of security bots. But you can't mix and match data types. So if your array holds booleans, you can't put strings, you can't put doubles, and so on. And the second rule is when an array is constructed, either literally or dynamically, it must have a set size. The computer can figure it out, or we can tell it, but it has to come from somewhere. You cannot ask for an array without also asking for a size. And this has to do with the fact that when an array is created, you may ask for an array of size 5, and in reality what you're basically asking is, let's say it's an integer array of 5 spaces, you're saying, well, I need enough space in RAM to hold 5 integers. And not only that, but they must be next to each other in RAM. And that may not seem important, but it's part of the reason that arrays are very efficient in terms of accessing, in terms of the speed it takes to access it. If you know where the beginning of the slot is, then you can easily jump to any of the other slots because they're all next to each other, they're all close to each other. You can imagine the analogy would be very strange. Imagine if you had one of these accordion folders, and if you open it up and you look at the first slot, and then when you go to the second slot, it's not in the accordion folder, it's somewhere else. That doesn't make sense. The whole idea is the accordion folder is one unit. They may be sliced into different pieces, but it's still one unit. And the same is true for our array. When you have an array, those spots are contiguous in RAM or memory, or continuous if you want to use that word. But they are considered one unit, and we can use an index to access any subpart. So let's go ahead and try this. Just as a refresher, really quick, last time we made two arrays. We made one called numbers. It was declared and then initialized with the new keyword to be size 5, so there are 5 slots. And then we made a second one called other numbers, which is a literal array, which is an array of size 3, right? There are 1, 2, 3 spots, and these values were filled in. We also saw that we could assign values to individual spots. It's like opening up that accordion folder and sticking something in each slot by referring to a particular index. And so in this example, we said the first index, because just like a string, the first spot is always index 0, gets the value 7. And the last spot, the fifth spot, or index 4, gets the value 10. And we mentioned that default values for primitive types are often preset, and so for integers, they would be zeros. And so we kind of tested this by running this program and showing numbers at 0, other numbers at 0. And remember, the at, that word at is the bracket notation. You might hear numbers sub 0 or other numbers sub 0. It really depends on what format you choose or style you choose. And then, of course, we also mentioned how this fails because 8 would imply a 9th position, but there are only 5 positions. And so this is a crash. And if I run this, we'll see that these first 2 lines worked, and the last line causes an array index out of bounds exception. And there it is, right? That third line is not going to work out. So let's go ahead and make sure that we comment this out. We'll put a note. This causes an array index out of bounds exception. A very wordy exception, but it's pretty clear about what it means. It says you're trying to use an index into an array that does not exist, and therefore that's a failure and the program must crash. So if I do want to, let's say, print out all the values in numbers, I could manually say print out numbers at 1, numbers at 2, numbers at 3, numbers at 4. But that seems like a really good situation to use a loop, because we're doing the same work repeatedly, and the only thing that changes is the index that we're looking at. Well, we've used loops to loop through characters in a string, so the same kind of logic would apply for looping through spots in an array. The only thing that's missing, and thankfully there is going to be a counterpart, is when we looped through strings, the control mechanism was typically the valid range of indices. So 0 being the first character, and then we would say the length method would return how many characters there were in the string. And so that length method of strings is what told us how many characters there were. So in an array, there is also something called the length property. Now, unfortunately, it's going to be kind of strange, and I know this kind of causes mistakes, and it's a kind of very common mistake for beginners, just because it's hard to remember sometimes, is that when it comes to strings, the length method is a method and therefore must have parentheses at the end. The length property of an array is a count of spots and does not require parentheses. It is not a method, it is a property or a public static variable or a public variable that we have access to. And so there is no set of parentheses. And so let's go ahead and write, we can obtain the number of array spots by using the length property. So for example, if I printed out something like number of spots in numbers array, and then attached. And so the way we would do this, the way you call the property is the name of the array dot and then the length property. So numbers dot length. And again, notice it turns green, and that means that would imply that it's an instance variable. That must be an instance variable of our array, and it is a set value, and it is how big it is. Now, it's kind of arbitrary here because I know it's 5 because I'm the one that chose it. But when we get to the point where maybe an array is passed as a parameter, we may not know how large that array is. And so what protects us is the fact that we can look at the length property. And we may not know the number exactly, but we could always code to the length property. Just as if we were writing code that was handling a string and a human typed it in, we wouldn't necessarily know how many characters there were ahead of time. But if we called the length method, then we would be safe in our programming. So the same thing applies here. So when we run this, we expect to see 5. And there it is, right? Number of spots. And I want to be clear that the length property is not the number of filled in values or non-default values, right? We only filled in a 7 and a 10. The other ones were 0. It's how many actual slots there are, spots there are, right? In the accordion folder, it's how many individual chunks or holes there are in that accordion. It's not how many are filled in, right? So it's not relevant what's inside of it, only the actual number of slots. And so with that said, if we did the same thing, but with other numbers, and we said other numbers, it's going to be length 3. Now, we never wrote 3, but the computer could figure it out by counting out the literal values. And so if I run this, we expect to see 3, and there it is. Now, let's go ahead and use a loop now to iterate through every individual spot in the array and display those values so we can see what's inside. And this is a very common technique. So what we're going to be moving on from with our arrays, and we've pretty much covered everything about arrays. They're pretty simple in their construction and their usage. But what makes them powerful is we can do all kinds of things. We can collect data in them and then iterate and manipulate those things. So for now, we'll start off small, printing everything inside. But we could maybe sum the numbers in an array of integers, or concatenate an array of strings, or get the average of grades of a student that are put in an array of doubles. So there's all kinds of things that we can do by grouping the content, which is like aggregation of the values in some meaningful way. So we're going to use a loop, and again, here's a situation where a for loop really lends itself to being useful because we know the starting index of all arrays. It's 0, always. We know the ending index, the last safe index of an array. If we know the array length is length, then the last safe index is length minus 1. This is just like with a string. And so let's make a loop that goes through all of the numbers spots. So we'll use a for loop. So for int, again, I'm going to use I as the classic variable, but you could put index or count or anything you want. And I'm going to start at 0. And this is, as long as the index is a good index, so as long as I is less than numbers length, and again, notice there is no parentheses because it is a property of an array, not the method of a string. And then we're going up by 1 index each time, so I++. And here we go. So we'll say, let's print out numbers at, and what I'm going to do is I'm going to concatenate a nice format. And so I'm going to say numbers at whatever index we're at. So we're at index I, which would be 0, 1, 2, 3, 4, and so on. And we'll say is equal to, and then the value. And now here I want to retrieve the value. And so we saw on line 41 and 42 the retrieval, the opening of that accordion and pulling of the content is using the bracket notation with an index. So I'm going to say plus numbers at, and here it's a loop, so we should change our index every time. So a good variable to use is the I variable. So we're saying the numbers at I is equal to the numbers at I. And so here we're just using the I as a literal display, 0. And here we're saying go to position 0 of the numbers array and get the content, right? So what we should see is numbers at 0 equals 7, numbers at 1 equals 0, and so on. So let's go ahead and take a look. And there it is. Notice there are 5. I did not say go up to 4, I said go up to length, and not including length. Well, that's a safe index, because if there are 5 spots, we went from 0 to 5, not including 5, which is the perfect range for this one. And notice something. These default values we did not insert. Those zeros were there when we constructed the array, because default primitive numbers are zeros. If it was doubles, it would be 0.0. If it were booleans, it would be false. I don't know about chars, but I know if we do shorts or longs or bytes, they would also be zeros. And then if there were a class type variable, strings, it would be a null reference. And we'll come back to more null references later on, because they are dangerous, but they do happen. But essentially, this array of integers is filled with only 2 values. And let's do one more. Let's do the same thing, but for the other numbers, and show that, again, even though we didn't dynamically construct it, we can still iterate through its content. We happen to know its content because we hard-coded it. We literally created it, but that's okay. So we'll say I is equal to 0. I is less than other numbers dot length. I plus plus. Remember, we can use I, again, because they are in different scopes. The scope of I is only the lifetime of the loop, and therefore we can reuse I each time. There is no shattering, there is no conflict. And we can say print out, and actually, instead of trying to type it out, let's just copy the line. The only thing that's going to change is we'll print out here, we'll put other numbers, and we'll put here as well. So when we run these, they're the first 5 from numbers, and they're the first 2 values from the literal array, right? The literal spot 0, 1, and 2 were valued with 2, 4, and 6, and that was what happened right in our literal array, 2, 4, and 6. And so that's the basis of an array, is we have multiple spots, we can loop through. And so let's go ahead and try this example. I think this is always a good example. Let's make a simple program that maybe asks a user, how many grades do you have? And then asks for the individual grades, keeps track of them, and then returns the average. And we'll make this simple. We won't make assumptions about, we'll say they're not going to put negatives, they're not going to put bad values. We can do something very simple. So I'm going to make a new class so we can try that out. So let's do a new class, and we'll call it grade array example. So a grade array example. And so here we go. We're going to do this in multi-steps. The first step we're going to do is we're going to ask the user to enter a number of grades. And so we're going to say, well, we need to ask the user for something, so we need a scanner. So we're going to say scanner, and I'll call mine KB like I typically do. We'll construct our scanner with system.in, so we're connected to the keyboard. We have to make sure that we fix our imports. Kind of going slow. There we go. We include our scanner. There's no error. And then now let's ask. So we'll go ahead and say, enter the number of grades to average. And so we will do that, and I'll get rid of the ln so it shows up on the same line. And so we're asking the user, tell me how many numbers I'm holding. And we'll say grade count is equal to, and then we'll use kb.nextInt to accept it. So they can't put in half a grade, so we'll take in a whole number only. And again, we'll make the assumption that they'll give us good data. So they might type in 3 or 7 or 0, and 0 is a valid index. We'll assume that they're not going to give us negatives, but we'll handle the case for 0 just because that's a good one to try out. So next, let's go ahead and build our array of the appropriate size. We now know how many grades they want to keep track of, grade count. Maybe it's 2, maybe it's 20, maybe it's 100, but it's grade count. So let's build an array of integers that is the grade count. So we'll say grade count. Well, it means we'll make a new array of integers. So there it is, integer array. I'll call it grades. And then we'll construct a new integer array of a particular size. And again, remember, the rule is you must give it a size. It could be a literal value or a variable that's a type int. So this works out nicely. We can say grade count. I missed the T in int. There it is. Oops. And so there it is. So now we have two things. We have how many grades they're going to put in. We have an array of that size. So if they said 5, this array contains 5 slots. If they said 50, this array contains 50 slots. The power that we've gained is I don't need to know how many slots there are when it starts, but once I know the number, I can make that much space in RAM without any fear of running out of space and without wasting space. So that's a really good advantage to have. And so now let's loop and repeatedly ask the user to enter one grade at a time. And again, we're not going to check if they've run out of grades or whatever. We're going to assume, well, they told me they want grade count grades, so we're going to ask that many times. So here we go. We're going to start at 0, or we can start at 1, I guess if that's a more comfortable thing to do. And while it's less than or equal to the grade count, so let's say grade count was 5, they wanted 5 grades, we're saying from 1 to 5. And if you count, that's 1, 2, 3, 4, 5 things. Or you could have done 0 less than grade count, that would have been acceptable as well. I goes up by 1 each time. What is the work of our loop? Ask for a grade, remembered in the array. So if we're at, and so this is actually one reason this does not work out so great. And starting with 0 actually tends to become more and more useful because arrays start at 0. So maybe we should fix this back to how I was going to originally try it. We start at 0 and we do not include grade count. So if grade count was 5, I want 5 things, but the indices that I'm going to end up using in my array are not 1 to 5, but 0 to 4. So that's going to protect us from index out of bounds exceptions. Right? This is an important array index out of bounds exception. It's important to avoid that problem. So let's go ahead and ask them to enter a number. So we'll say, and I'll get rid of the ln because I want it to show up on the same line. Enter the next grade. And there it is. And then now I could put it in a variable and then put that variable inside of the array, or I can just put it directly in the array. So I'm going to do that. I'm going to say grades at I. So if it's 0 the first time, it's equal to kb.nextInt. They're going to type in a number. And it'll sit there and wait for them to type in a number. So this loop will repeat itself grade count times. And theoretically, at the end, we should have some number of grades in our array. And then now we can sum them and get the average. Now, I know I could do this all together, but I'm doing it in separate stages just because it's easier to visualize the looping instead of doing it all at once. So we have, let's go ahead and put a note, make space for all the grades, all right, fill in the grades from the user, and now the next step is going to be sum the grades to average. So another loop to loop now, not some number of times because of the sake of the user, but for our array. So we'll say for. Again, I'm going to use I again. I'm going to start at 0 because that's the index I want to use in the array. I is less than, and again, now I could use grade count because that's the same number, or I could use the length property of the array because they're equivalent, right? We established that the length of this array was grade count. But I'm going to use the length property just to be comfortable and consistent with that idea. And so we'll say grades.length and go up one at a time. What are we going to do? We're going to sum the grades. So let's go ahead and make the sum. Now I'm going to make this a double because if I'm going to eventually divide, I don't want to lose the fractional answer. So a double type would be a convenient thing. So we'll say double sum. And we'll initialize it to 0 so that we don't have a problem. Sum is going to be added and reassigned whatever the current grade is. So what grade am I looking at? I'm looking at the grades array at whatever index the current loop iteration is at. So grades at I. So this sums the grades to average. And then the last step is to divide that total by how many grades there are. And so now I can say double average is equal to the sum divided by, and again, I could use grade count or I could use the length of the array, and I'm going to use the length of the array, grades.length. And then we can print out a message, your average was, and then we'll say average. Now this is going to work pretty well, and then we're going to find there's hopefully, if you think about it, look at this carefully, you might be able to find the flaw. While I run this, you might be able to spot the danger that we've kind of ignored. So here we go. Enter the number of grades. I'm only going to put 5 grades. 5. And there's the first time. So I'm going to say a 77, and a 92, and then a 95, and a 100. And here's the 5th one. Let's do an 88. My average was a 90.4. That's a pretty good average. And there it is. Notice it did all the work. It repeated itself several times, and it was successfully stored stuff in the array, retrieved stuff from the array, summed it, and gave us the average. Now, if I run this again, hopefully you'll see the flaw before I run it. Give yourself a moment and think about what is wrong with this. And I mentioned at the beginning that I was allowing 0 grades. And so here is the danger. If I say the number of grades to enter is 0, your average was NaN. NaN stands for not a number. And so why did this happen? The length was 0. We had sum divided by 0. Right? Unfortunately, there are no grades, so this loop doesn't happen at all. Sum is 0. Grades.length is also 0, and we're dividing by 0. And I'm surprised it didn't give us an exception. It gave us a not a number, which is nice, but the point is it's still incorrect. So perhaps we should ask a question before we do the average. We say, hey, is there an average to have? So let's ask that question. We'll say if grades.length is greater than 0, then we can safely get an average and print it out. And so let's give it that space. And let's say else. And we'll put out a nice little message. We'll say, no grades were entered. You had no average. Right? And so let's try it again. So I put 0. No grades were entered. You have no average. And if I run it again, let's go ahead and try 1. My average is 100 because the 100 divided by 1 is 100. And there it is as a double. So again, the takeaway is that arrays are very useful. And here it's a flexible thing. Because if you think about it, could you, without an array, could you make a program that handled any number of grades dynamically? And the answer is pretty much no. Because if you made 10 variables, you could hold 10 grades. But if they typed in 25, so unfortunately Java is not a language where you can dynamically generate variables. You can generate content, you can generate objects in RAM, but if you're going to refer to them in a variable in your code ahead of time, the coding portion is before the program is running. And so the idea that you could create variables that don't exist on the fly while it's running, Java does not do that gracefully. Some languages in fact do allow for that really complex situation, but Java doesn't. Once it's compiled, you can't change it. So the idea instead is that we can make a variable that will eventually contain content, and we can dynamically fill in this much RAM with that value. But once we're past line 15, that's it. There are that many slots, and there's nothing we can do about it. Right? Or you might argue, well, you could make a bunch of variables and hope that they don't go up with a number. Right? Make 100 variables, and they only put in 10, and then you can fill in 10. But then how would you know which variable to fill in, and what happens if you left blank ones, and what would the default values be, and so on. So there's a lot of challenges if you try to do it that way. And so arrays are very flexible ways to handle content. So I'm going to stop the video here. I think this is enough to kind of get going with a lot of ideas. The next video, what we're going to be doing is, one, we'll be using non-primitive types. That's a big deal in itself. So not just ints and doubles and stuff, but maybe strings and other objects that we've created. And we'll also handle the idea of passing arrays as parameters and returning arrays as values as return types, because arrays are objects, and so you can if you can return a string or return a double, you can return an array. And that may seem complicated, but it's a good tool to have, and it gives us a lot of control over our programs. I'll see you in the next video.